Okay, let's go ahead and graph some trig functions. All right, so we've got y equals cosine theta, and we're going to use the unit circle for a little help. So remember back in middle school when you were asked to graph something and you just would make a table, right, and then plot points from it. That's what we're going to do with these trig graphs at first, at least until we understand their patterns. And so anyways, we think about theta. Okay, theta is the angle, and we look at the angles are in this greeny, olivey kind of color. Maybe it looks gold on your side. But anyways, we're going to pick the easy one. So we're going to pick 0 is an easy one, right? Because when the angle is 0, what's cosine? Cosine matches up with the x value and the coordinate plane. So cosine of 0 is 1. That's pretty easy. The next easy one is pi over 2. So we're going to use the easy ones just like we did in middle school. Remember, like in middle school, we picked -1, 0, 1. All right, so pi over 2 is easy because cosine of pi over 2 is equal to 0. The next easy angle is pi, right? Because cosine of pi matches up with the x1, and that's -1. Let's extend this down a little bit. The next easy angle is 3 pi over 2. And 3 pi over 2 cosine is 0. And then we've got the last easy angle is back around to 0, 2 pi, right? 2 pi is our last angle, and we're back there where cosine is equal to 1. Okay, so we're going to get rid of the unit circle because it helped us for a second, right? So let's go ahead and get rid of it. Let's pull it down. We don't need it anymore. And let's get rid of these squares, shall we? So what we've got is we've got our table. And once we have a table, we want to set up our tick marks so that we can graph, right? We can graph our coordinate plane, our coordinate points, rather. All right, so here we go. Let's keep them the same color. And
just a reminder, there's a PLC meeting in 5 minutes.
Okay, thanks for that reminder. All right, so let's go ahead and label our tick marks. We have 0, and then pi over 2, and then pi, and 3 pi over 2, and 2 pi. And we know our y values, our cosine, right? Our y equals cosine. We've got 1, 0, -1, 0, 1. So we're going to make sure we have a 1 and our -1. And all we're going to do is we're just going to plot our points. So let's get some plotting going on. So 0, 1, and pi over 2, 0, and then that's a -1. So I'm just plotting these points. Now, you saw the unit circle, and you know if we kept going around the unit circle again, you know, past 2 pi, we would continue the same pattern, right? Up the 1, the 0, the -1, 0. If we wanted to, we could keep going. We could keep going on the other side, too. There's just this pattern going on. But we really only wanted to do the tick marks for one of the periods, one of the patterns, because it's just takes less time that way. All right, so if we were to connect the dots, we might put something together with straight lines that look like Charlie Brown's t-shirt, and we don't want to do that. The cosine is, the graph is a curve, just like the sine graph is a curve. And if we wanted to take the time, we could use angles like pi over 4, where cosine is √2 over 2. We could graph those other points, but to save time, we're going to say, we already know. We're going to go ahead and connect these points with a nice curve, remembering that we can't go above these max points, and we can't go below the min points. All right, I guess I could go up there. All right, and so what we're looking at, the main part, because I really just asked you to do one period, is this part. But the graph goes on and on and on both sides. And so they're asking us about our amplitude. And amplitude is simply the distance, can you even read that writing, from the midline to the max. And so when we look at the midline is the x-axis, right? It cuts right through the graph, it cuts right through the middle, it's the midline. And the height from midline to any of the maxes, well, that's going to be 1, right? So amplitude is 1. Period is, I mean, I look at my writing, I was like, how could you even read that? Period is the distance of the pattern from start to finish. And that's not exactly right. It's the start to finish of one pattern. Let's put that. The distance, the pattern from start to finish. All right, well, we're gonna know what this means. Look, here's the pattern. 1, 0, -1, 0, 1. From start to finish, the pattern was completed from 0 to 2 pi, so our period is 2 pi. Period's 2 pi, amplitude is 1. Hopefully you can read my writing. All right, let me check real quick on the time. All right, let's keep going. So we're going to keep, let's see, what do we find out just doing this? Well, if we've got cosine theta, we note that we have a theta here. Our tick marks are always going to be the same, from 0 to 2 pi, right? Cosine itself has the pattern 1, 0, -1, 0, 1. So we're going to use those two things to graph this one. This one's a little different because we see a 2 in front of the cosine. And so we know that when we see just a theta here, there's no, like, look, if we look ahead, oh, look, theta has company here. We're going to deal with that next. But here, theta is by itself. That means that the tick marks are automatically the 0, pi over 2, pi, 3 pi over 2, and 2 pi. Every single time, guaranteed. If theta is alone and theta is our angle, then those are our tick marks. All right, so since we already have our tick marks down, I'm going to do this. I'm going to be like, I don't have time to fill out this table. I'm just more concerned with the pattern of cosine. So when I go back, I'm going to remind myself what the pattern of cosine is. It's 1, 0, -1, 0, 1. So we remind ourselves, okay, cosine is 1, 0, -1, 0, 1. All these interruptions. All right, now, so we're done with theta. We did the tick marks for theta. And the next thing that we're done with is the pattern of cosine. What is left after that is the 2. See how we have a 2 in front of our cosine? Can you see that the 2 is being multiplied by the cosine? Basically, that means we're going to take our pattern and multiply it by 2. So we're going to multiply the pattern by 2, each one. And these are the points that we are going to go ahead and graph. So we're going to go back over to our XY coordinate plane, and we want to go ahead and make sure we have 2's in there. So let's go ahead and label. We got a 2, we got a -1 and -2. So we're going to go ahead and just plot those points. So we've got a 2, 0, -2, 0, 2. If you wanted to and have fun with more of a, you know, zoomy, curvy, you could keep doing what I'm doing and get the dots, get the whole pattern going. But once again, on the test, on the practice, I'm really just asking to see that you can do one period. All right, amplitude. Amplitude's the distance from the midline to our maximum point, and we can see clearly that our midline is right here, and the distance from our midline to our max is 2. You may also notice that this is a 2. That is our midline, all right? I'm sorry, that is our amplitude. So there's 2 ways to find the amplitude. I like to teach it from the midline because, like in Delta Math and on the test, you're going to be expected to be able to find the amplitude from the graph. So it's good to know it both ways. The equation tells us that if there's a number right in front of the cosine that's being multiplied by the cosine, that is going to be our amplitude. All right, period. Let's see. We start our pattern at 0, and we finish our pattern at 2 pi. Therefore, our period is 2 pi. Okay, our period will always be 2 pi as long as theta doesn't have any company. All right, this is one of those things where the more we do, the more it makes sense. So we're going to keep adding. We're going to keep adding layers. And so we see, oh man, this one theta has company. All right, if theta has company, we have to do something that we haven't done before. We normally said, oh, you know, if it's just a plain old theta, we start at 0 and we end at 2 pi. Okay? That's always going to be true if it's just theta. But as soon as we see that theta has company, we set the whole thing. We say, well, we used to start at 0, so we're going to set 2 theta equal to 0 to see where our new place to start is. And we used to end at 2 pi, so we're going to set 2 theta equal to 2 pi. And then we're going to solve for theta. We divide both sides by 2, and we get theta is 0. Divide both sides by 2, we get theta is pi. So that means that this time around, our pattern starts at 0, and it ends at pi. So when we go over to do our tick marks, we're going to be really careful not to just be on autopilot, right? We're going to start at 0, and if you note, if you go back to your other graph, how many tick marks did we have? We had 1, 2, 3, 4, 5. We completed a complete pattern in 5 tick marks. So we're going to use 5 tick marks here. So 0 is going to be my first tick mark, and then 1, 2, 3, 4, 5. Pi is going to be my last tick mark, and now we're going to play meet me in the middle. Who's in the middle between 0 and pi? That's right, pi over 2 is in the middle between 0 and pi. Let's play meet me in the middle again. Who's in the middle between 0 and pi over 2? Pi over 4. Right? Who's in the middle between 0 and 1/2? Right? 1/4. Who's in the middle between 1/2 and 1? Right? 3/4. So 3 pi over 4. All right, so we got our tick marks down. So now we do the same thing we've been doing. The only new thing this problem had was we had to stop and find out where's our new starting point and ending point. We had the same starting point, didn't we? But not the same ending point. So that meant we had to do some new tick marks. All right, let's do our table. And once again, we don't have time to write our tick marks down. We're just concerned about the pattern. So let's write the pattern. So the pattern for cosine is always 1, 0, -1, 0, 1. And oh no, we see, so we just did cosine, we did the pattern, but we see that there's a number in front of cosine, right? And that number is 3. So our pattern is going to get multiplied by 3, just like we did the last time, right? All right, so then when we come over to our tick marks, we want to make sure that we label it correctly so that we can account for all of the points that we need. Okay? All right, and let's go ahead and do our little, we got 3, 0, -3, 0, 3. So we've got 3 and 0 and -3, 0 and 3. We could stop here. I don't know why I feel the need to just keep going, but I kind of do. I think it just looks better. All right, so we're going to connect them in a nice curvy way. Yeah, it's not the best. All right, that is not the best, but you know what I'm trying to do. All right, there's our graph. Let's talk about amplitude. Amplitude, we can find it one of 2 ways. We can see that there's a 3 in front of our cosine. That's our amplitude, or we can find it from the graph. Midline is right here on the x-axis. Max is 3 away. So our amplitude is 3. Okay. Then they ask for the period. Well, if we start our pattern at 0 and we finish it at pi, the distance is pi, right? To find the distance between 2 points, like if I said find the distance between 2 and 10, you would say 10 minus 2 is 8. The distance between the 2 is 8, right? So we just take the end point minus the beginning, and that's what we get for our period. So that's going to be pi. Then it asks, hey, horizontal shift. All right, horizontal shift means this. If we started our pattern on a different place than 0, then we would have a horizontal shift. But there's none right now because we started at 0. Okay, I know I'm going fast if this is your first time seeing it, so slow me down, back me up, like, you know, pause, do all those things. All right, where'd that problem go? All right, so here we've got a lot going on. We're going to start with our angle has company. All right, so as soon as we see, and we're like, wait, isn't our angle supposed to be theta? And yes, we like to use theta for angles, but sometimes delta math uses x. Sometimes you'll see an x, and so I want you to get used to that. It's still the same thing. It's an angle. The angle has company. Theta has company, x has company, whatever. So if x has company, we know what we're going to do. We're going to take x and the company. We're going to set it equal to 0 to find where do we start. Oh, we're going to start at negative pi. We're not even going to start at 0. We're going to start at negative pi. So that'll be fun. And we're going to set it equal to 2 pi to see where we end. So we subtract pi. 2 pi minus pi is just plain old pi. All right, let's get strategic here. There's 5 tick marks. We are going to, our first one's going to be negative pi, our fifth one's going to be pi. Who's going to be in the middle? That's right, 0 is going to be in the middle. So we'll put 0 here, leave a space, let's put our negative pi, leave a space, let's put our pi. Meet me in the middle between 0 and pi, of course, pi over 2, between 0 and negative pi over 2. All right, we got our tick marks. Once we got our tick marks down, then it is doing what we always do. We say, no, thank you, ma'am. There's no time to do that part, but we have kind of put our pattern in, don't we? And pattern for cosine, so now we're going to do cosine. And cosine is 1, 0, negative 1, 0, 1. All right, we're done with that. Okay, now, this is where it can get tricky if you are not paying attention. So pay attention. See this 3 right here? Some people are like, oh, we got to multiply the pattern by 3. But I'm like, that's not a 3. That negative belongs to the 3. The pattern is being multiplied by negative 3. All right, so be real careful with that. So we're multiplying by negative 3. We can do that. Okay, now that's not all. We got this random 2 here. I know it looks weird. If we wrote it differently, if we wrote it kind of like y equals 2 plus negative 3 times cosine x plus pi, et cetera, it would make more sense that we're like, oh, I get it. X has company, cosine pattern, multiply the pattern by negative 3, and then we're adding 2. So hopefully you can see that that's really, these are the same thing. It would look weird if we wrote it this way. All right? So here we go. We've got to add 2 to our pattern, and that's what we're going to do. Let's add 2. Is that a negative 3? No, that's a positive 3. Okay. Whew. Plus 2, it's 2. Plus 2 is negative 1. Gosh, what does that even look like? All right, so let's go ahead and let me get rid of this whole thing. Okay, let's go ahead and graph. Now we have to be really, really careful when we're plotting these points, because what happens is we're so used to starting at 0 that we're just like, you know, random. We just start at 0, and we can't do that. Oh, real quick, let's adjust our y tick marks. I'm going to need what? We're going to need to go up to 5. So I'm going to go ahead and do 1, 2, 3, 4, 5. So stop and somehow adjust. 1, 2, oops, don't know what I'm doing there. 3, 4, and then 5. Negative 5, these are negatives. I didn't even need to go that low, did I? Oh well, I just needed that negative 3. All right, here we go. We are going to be very, very, very careful, because this negative 1 goes to our first tick mark right there. All right, so we are going to go ahead and start with our first tick mark and put a negative 1 there. And then we've got a positive 2. Then we've got a 5. Then we got a 2. Then we got a negative 1. And we could just keep going, right? Okay. Enough of that. Oops, I'm missing my dots. Hopefully you're doing a better job. Okay, so there we go. We've got the graph. We know the amplitude. We've got to be really careful. We can look here and see that the amplitude is 3, but make sure you can do it from the graph as well, because you're going to have to do that on the test. So the midline of this graph is right here at 2. Can you see that? That's where the graph gets split in half. The distance from the midline to one of the max points is 3, right? So our amplitude is 3. Our period, well, let's see, we started at negative pi, we ended at pi. We travel from negative pi to 0, we traveled pi, and then 0 to pi is another pi, so that's going to be 2 pi. Once again, another way to do it is just take your end point and subtract your beginning point. So pi minus negative pi is pi plus pi, which is 2 pi. All right, horizontal shift, yes, yes, yes. We don't want to write negative pi because we want to write it as a distance, and distance can't be negative. So we'll say to the left pi, to the left pi, pi to the left, All right, if you forget and you write negative pi on the test, that will probably be okay with me, but let's try to practice this way. To the left pi, pi to the left. All right, there is no line for vertical shift, so let's add that because there's certainly a vertical shift, right? 2 is our vertical shift. You can see it from the equation, you can see it from the graph. When our midline is not 0, that means we have a vertical shift. Wherever our midline is, that's our vertical shift. Let's say the vertical shift was -3. We would say down 3. Okay? All right. One more. Let's check on the time. How we doing? Okay, sorry, 20 minutes. All right, let's go ahead and do the last one, graphs of sine. So you're going to get the idea that we're going to do the same thing as we did in the first one, but our numbers are going to be different because it's sine, right? But we're going to use the same simple ones. We're going to use 0, and when we look at the unit circle, sine of 0 is 0. And then we're going to look at the next easy one, pi over 2, and sine of pi over 2 is 1. The next easy one is pi. Sine of pi is 0. The next easy one is 3 pi over 2. We look at the unit circle. I'm running out of space. 3 pi over 2 sine is -1. And finally, back at 2 pi, sine is 0 again. All right, let's get rid of the unit circle and all my little squares, rectangles. All right. Oh gosh, that's a teeny little eraser. All right, and here we go. So we're going to notice that we've got the same tick marks, right? We got the same exact tick marks. We've got 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. But we'll notice that we have a different pattern. Instead of 1, 0, negative 1, 0, 1, we start with 0. And it makes sense because sine starts with S, which sounds kind of like 0. Sine, 0, go with it, all right? So sine starts with 0. But it's got the same, we can do our, we've got our 1, we've got our -1. Let's go ahead and put our points in. At 0, we've got 0, 0, and then we go up, and we go back down to 0, and then we go down to -1, and we go to 0, and we could keep going, right? Same thing that we did with cosine, we do with sine. It goes both ways. You don't need to do this on a test. You just need to show me one period, but it's kind of nice to see that it's a curve that goes on and 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 on. Okay? All right, amplitude, same thing. Distance from midline's 1 to the max, or you could see right here, there's a number 1, but you don't really see it. Period, we start at 0, we end at 2 pi. There we go. Okay. So everything we learned about shifting cosine around and the patterns and all the stuff that we do the same thing with sine. The only difference with sine is the pattern starts with 0. 0, 1, 0, -1, 0. All right? So I think after this, yeah, we've got some paper homework. We've got some Delta math. It says, oh, let's do the first two together. All right, I guess we're going to do that in class. All right, thanks for joining me. I will see you in class.